So welcome to the Mission Earth Solar Eclipse webinar. Kevin Sekowski from the University of Toledo. We have some speakers tonight. They're going to tell us about the solar eclipse for August 21st. As usual, let me share my screen. So, this is as part of our Mission Earth project. We thought we'd have a solar eclipse webinar before the end of the school year. I know some of your school year just ended. And just an overview, Mission Earth is part of the it's a NASA grant from the Cooperative Agreement Notice. We have University of Toledo, Boston University, West Ed, Tennessee State, Berkeley, NASA Lang. And then tonight we have Michael Cushing. He's an associate professor in the Department of Physics and Astronomy at the University of Toledo. And then Steve Edberg, who's a science outreach specialist at JPL. Sarah Merzwiak, she's going to give some websites. And then Jill Teague, I'm blanking on where Jill's from. I think she's from NASA Langley, and she's going to do a little talking as well. Oh, you know what? And all the projects are over. So the symposia, not all. We had our symposium in the Midwest this past weekend. It went really well. And just a reminder that the annual meeting for Globe, July 30th to August 3rd in New Haven, Connecticut. People are making plans to go to the meeting, and students are hoping to present. Stop my sharing. And introduce Michael Cushing. Michael?
Hello. Let's see. So I should start my screen sharing. Do I need to be on, or am I on the big screen or no?
You will be usually when you talk, or Janet can switch.
There we go. Okay. I'm going to share screen now. So I'm just going to briefly tell everyone about the eclipse that's happening on August 21st, 2017, and we're calling it, we as in the astronomers are calling it the Great American Eclipse. And the reason why is because if you are anywhere in the continental United States, you will get to see some part of this solar eclipse. This is sort of the big picture summary of what I'm going to talk about in the next few slides or so. There's something called the path of totality. If it happens to be in this path, the sun will completely go away. The moon will pass in between us and the sun and block the sun out completely. And then it has the times when that happens along the path, starting going from Oregon all the way down to South Carolina. If you are not in the path of totality, you will see what's called a partial solar eclipse, where part of the sun is covered. And so as you can see, we're sort of in the 80% level. So roughly 80% of the sun will be covered up. If you go.
Hello. All right.
Hello?
Well, it's probably too soon. It's still too late.
Please.
Should I keep going, or is that someone trying to talk to me?
We're not trying to talk to you. Somebody didn't realize we're meeting.
All right, I'll keep going then. So in the Toledo area, we're going to be at sort of the 80% level. It will get noticeably darker here, but it's not going to be totality. And so if you can find a way to get in this path of totality, you will see quite a show on that day, assuming the weather is clear, of course. So I wanted to go through a few things. And the first is, why do eclipses occur? And to do that, we have to talk about how shadows form. And so we sort of are very used to shadows, right? You have the sun out, you're walking along, and you have a shadow on the ground. But it's slightly more complex than that. And so the way to look at it is, imagine you have a very small light source, what astronomers call a point source. And then you have a blue object in the middle here that's blocking some of that light, and it will cast a shadow on a surface, this black vertical line. And if you look at it, you will see lots of yellow light, but there will be this shadow cast by the object, and we call this the umbra shadow. The problem is that the sun is not a point source. You can go out during the day when it's not cloudy and see the sun. You can see the surface of the sun. It's about 1/2 degree on the sky, so it's extended. And so when that happens, the shadows get more complex. In particular, you get not only the umbral shadow, which is this deep, dark shadow where if you are in it, you literally can't see the light source. But there's something called the penumbral shadow. And this is a part of when you're on this screen where you can see part of the sun. And so you're in sort of a gray darkness. And it's sort of diffuse. And if you want to do the geometry, you can draw the lines and figure out where the umbral shadow is and the penumbral shadow is. And so this sort of cartoony thing here is sort of set up perfectly for the Earth and the sun. The sun is yellow, the Earth is blue, and so that's exactly what I'm trying to say. And so here's a diagram of what happens. So the moon goes around the Earth, and there are times when it happens to pass perfectly between the sun and the Earth. And when that happens, you have an extended sun, you have an object, the moon, and so it casts both an umbral and penumbral shadow. And if the Earth is in the way, that shadow sweeps across the face of the Earth as the moon orbits around the Earth. And it just so happens that on August 21st, the Earth will be turned such that the US, the continental US, will be in the path of the shadow. Other eclipses happen in the Pacific Ocean and no one sees it. Maybe the fish do. Other eclipses happen on Africa or Europe. And it just depends on when the eclipse happens and where the Earth is turned at the time. And so in this case, we get lucky. The continental US gets to see a total solar eclipse. And obviously, as I said, this is not to scale. This is a picture of the umbral shadow on the Earth taken from, I suspect, the space shuttle. I think that's the arm from the space shuttle. I don't think it's the ISS, but I think it's the space shuttle. And you can see it's literally a shadow that gets put on the Earth. And so if you were under that, you get to see this beautiful total solar eclipse. And I'll show you some pictures of that in just a second. Just to get a sense of what happens, here's the Earth. And as I move the movie forward, you will see the shadow of the moon, the umbral and the penumbral shadows sweep across the continent. And you've got the times over on the left there if you're interested, wherever you are. So right now it's the penumbral shadow moving in, and then there's that little black dot in the middle. That's the umbral shadow. That's the totality part. So if you are under that, the sun completely disappears. Everywhere else, you get a partial eclipse. And of course, you can see this covers, much of North America, but certainly the continental US. And then eventually, at something like, 3 o'clock, it moves off the coast of South Carolina and just keeps going in the ocean, right? And then eventually it will pass off back into space. If you want to see sort of what people will see in different spots of the US as far as if they look up at the sun, this is another movie showing that. And it will zoom in just a second. These are the penumbral shadows. And then here comes in black, the little dot, the umbral shadow. And so you can see in Salem, you get a perfect total solar eclipse. Whereas places off the line, you don't. Casper, Wyoming gets a great view. Omaha just misses it. Nashville, be a good view. I mean, you can see up in Toledo, we sort of get an almost total eclipse, something like 80%. Here are some pictures of what a total solar eclipse looks like. You can find these anywhere online. These are just some of the ones that I found interesting. You can actually see the shadow on the sky. So you've got the light parts on the left, and then you've got this sort of giant shadow over you from the eclipse. Here's what it looks like somewhere in a cold place where everyone decided to get bundled up and go out and watch it. Here's a zoom in of the sun. You might ask, if the sun's blocked out, what's all that white stuff around the sun up there? That's the corona of the sun. And so there's a little bit of light that comes around, but the bright surface of the sun that we're so used to seeing in our daily lives is what's blocked out. And so it's this sort of lighter diffuse light that you never see, that you get to see during a total solar eclipse. Here's another example. This is called the diamond ring effect, because just before totality happens, the last little bit of sun is sitting there and it kind of looks like a diamond ring. This is a really cool movie that I found. There are planes in the air, and if they happen to be flying in the path of totality, they get to see a a total solar eclipse. And so here's a sped up movie of someone in an airplane watching a total solar eclipse. And you can actually see the shadow sweep in. There it comes. It now covers you. And now you can see it sweep and keep going. And so think about how fast that shadow is moving, right? Planes move at like 500 miles an hour, something like that. So this thing is moving at 500 miles an hour, and the shadow catches up to it and passes it. So the shadow is really moving very quickly across the face of the Earth. Some safety tips on how to view an eclipse. Just want to say straight out, never look directly at the sun without some form of eye protection. It's really the thing you want to stress. There are times you can do it, but you've got to say one statement, this is the one you want to go with. So this is not how to do it, right? You don't stack up a bunch of sunglasses, because that's not going to protect your eyes. You know, you might think, oh, I can use some eclipse glasses and a telescope. That's not good either, because the telescope is collecting more light than your eye would and then focusing it down into your eye, right? And those eclipse glasses are designed for your eye, not for more light being jammed through it. So don't do that either. And as a general rule, you don't want to use clouds as a solar filter. You know, the idea is when you go outside and you look at the sun, you can't do it. Your body says that hurts, stop it, right? So trust that instinct when you're looking at these things. Don't fight it. The cheapest way to do it is buy some eclipse glasses. They're a couple of bucks. You can order them online. We sell them here at the Ritter Planetarium. They're really cheap. You can just throw them away later if you want. You can put them on and you can safely view a solar eclipse. But if you don't want to spend a couple of bucks or you don't have time, there's other ways of doing it as well. One is what's called a pinhole camera. You can, I don't want to get into the physics of cameras, but you basically poke a hole in something and hold it up to the sun, and it will cast an image of the sun on some piece of paper or the ground, or what they're labeling as the projection surface, which is just a fancy way of saying whatever the light happens to hit. This is a picture of an actual pinhole camera. So you can see the pinhole down in the lower right-hand corner of a piece of paper, and then on the ground, they've just dropped a piece of paper, and you can see that little white thing is the sun. And you can sit and watch the eclipse happen. You'll see the sun get eaten away as it happens, and that's a safe way to view an eclipse. If you don't even want to do that, it turns out nature can provide pinhole cameras for you. You look up under a tree, the leaves make all sorts of little pinhole cameras. Every little spot on there is effectively a pinhole camera. And so if you look under a tree during an eclipse, you will see something that looks like this, which is tens, maybe hundreds of little eclipsed suns. And so you can just stand under a tree and do it that way if you want, if you don't even want to do it. And if it's even worse and you really you don't have a tree in your neighborhood, or you live in the desert and you have a cactus or something, just go get a colander out of your kitchen and hold it up. And the little holes in the colander will act as a pinhole camera, and you can see the eclipse happening. The time you can look at an eclipse directly with your naked eyes is during totality, because at that point the bright part of the sun has been blocked, and so you can look at it. But that's only when you're in totality. And so if you're in Toledo, you can't look at the eclipse ever without some form of protection. Only if you're in the path of totality can you do it. So just for the people in Toledo, the view that we're going to get from Toledo, as I said, is not full. It's not a total eclipse. This is what will happen during the eclipse. So the sun is the big thing in the middle, and the circle off to the right is the moon. You don't see the moon, but this is what's going to happen. So there's first contact when the moon first touches it, and then it will slide across the face of the sun and block something like 80% of the light from the sun. So that's maximum eclipse. And then it will keep moving through space, and the eclipse will end. And like I said, in speaking to people who have gone through partial eclipses, at 80%, the sky will darken. How did that happen? Sorry. The sky will darken, It will not be a total eclipse where the stars come out and you can see planets and things like that, but it will get noticeably darker. And the times when it happens, it's basically well set for the afternoon. So the start of the eclipse is 1 p.m. That's when first contact happens. The maximum of the eclipse is about 2:30. And then the end time, when the last bit of the moon moves off the sun, it will be about 4 o'clock in the afternoon. So on August 21st, you've got 1 to 4 o'clock. You can go out, grab a chair, grab some eclipse glasses, and watch a pretty amazing show that the universe puts on every once in a while. And so I just want to remind people, because Toledo does not get a total solar eclipse, you can't look at it with your naked eye. You need some form of eye protection. And sunglasses is not enough. I just want to do a quick plug for the people in Toledo. We have the Ritter Planetarium here on the main campus of the University of Toledo. We do public programs on Fridays throughout the calendar year, and on Saturday afternoons during the school year we have children's programs. So we sort of focus them more for younger children. We also do school programs. So if you have kids in school and they're looking for field trips, we do lots of programs with schools in the neighborhood, going out to something like 50 miles. Birthday parties, private events we also hold. And so if you'd like to see more information about that, you can go to ritter.utoledo.edu. And thank you. And I'll take any questions that anyone might have.
Michael?
Sorry, I'm trying to stop the sharing, but my mouse seems to have... Oh, there we go.
I know it tends to get slow.
There we go. I got it.
So anybody has any questions, ask Michael. This would be a good time to do it.
What about welding goggles for looking at the sun? Yes, welding goggles will work. You have to get the right, there's some scale that welders use, I think, to rate the extinction of the glasses. But there is some number above which or below which, depending on how the scale works, that they will work. So yeah, look, you can Google it and it'll tell you what the right number is. I don't know it off the top of my head.
I have a question.
Sure.
So all the times are in Eastern, I'm assuming. So as you know, we're all globe practitioners, and we're making a hypothesis that there's going to be some potential change in temperature and surface temperature or other. So in your experience, having studied this for a long time, what would be your hypothesis about what kind of changes in temperature or other?
Sure. Well, having studied it for actually no time, I will still make a hypothesis because, scientists can do that. Actually, that's a good, so it's 3 hours long. So I'm trying to think. I guess it's a question of where you are. If you're in totality, that's different than if you're at 10%, eclipse. So if you're in 10%, I would expect no change in temperature. If you're in totality, you're only in totality for, I think it's a couple of minutes, but you're going to have the penumbra sweep over you first, and then you get totality. I could see maybe a change of temperature a little bit, a degree or two. I don't think the temperature is going to drop 20 degrees, but that's just my completely uneducated guess. So.
Yeah, I'll throw my, I don't know what it is, but we sent instrumentation from Globe to Indonesia last year because there was a total eclipse in Indonesia, and the temperature dropped about 2 degrees Celsius. So
okay, 2 degrees.
Yeah, and that's.
I didn't say what unit, so I'm still correct.
That's great. Yeah, and it's similar. I think there was an eclipse in '94 that went through Michigan, and I didn't take any temperatures, but I noticed it got cooler.
Yeah.
Other questions?
There was a pretty well studied eclipse in 2015 over the UK as well, that we linked on the Globe website. They did a big citizen science study and found a average temperature decrease of about 1 degree, but up to 3 degrees Celsius
Okay.
across the UK.
So someone just asked, can you use a mirror to project the eclipse? So the short version is no. It's almost like asking, can you take a picture with just film, right? You need to focus the light to make an image. And so you can use a telescope to do that. You could, in principle, use a telescope and put a piece of paper at the focal plane of the telescope. That's a possibility. You might want to use a solar filter on the telescope so that you don't burn your piece of paper. But you can use mirrors and lenses to do that kind of thing. But again, don't put your eye at the focal point because that's bad.
I have a question for Jill about that 2015 solar eclipse that you mentioned. Was there any other globe data collected besides temperature? Were there clouds or even wind speed or anything like that?
So they weren't collecting using globe protocols, but they did collect temperature, wind speed. I don't think the citizen scientists did clouds, but they had a bunch of weather stations that did clouds, and they did see changes in wind speed and some in wind direction as well. Yeah, I can link to those studies. They were pretty neat.
Yeah, it'd be interesting to see, especially wind speed, because that's what I had the feeling that maybe that would change, especially in totality.
Do they perform a control on that? I mean, you could imagine randomly taking, checks of the wind speed, and it might go down or up during any 5-10 minute period. So is there a way to have causation link? I mean,
It's a good question.
That's a good question. I just shared my screen. This is the link that Jackie Kane just shared. Jill, do you know who, or Todd, do you know who posted this?
I don't know.
It's on the NASA.gov website. I was actually on a NASA call today, and it was about everything on the NASA website scientifically. It would probably be, I guess it's not a scientific statement, but we'll find out this summer. We'll talk about that the temperature difference between the day and night, low and high, that the temperature will drop 3/4 to a half of the maximum day-night temperature difference. My guess would be it wouldn't be that great. But what we've seen, it hasn't been that large. It hasn't been that large. Oh yeah, so Jackie asked, what other variables would be significant to measure besides temperature? We're just doing surface temperature, air temperature, and clouds for globe. Does anybody else have any thoughts on what other observations that could be interesting? Yeah, so I see, Sarah, you typed in wind speed, direction, map web protocols, barometric pressure. It's interesting. Humidity might be another thought. You have less energy, solar energy going into evapotranspiration. For that 1.5 to 2 hour period. The challenge, like as Michael said, is what's the how do you compare it? How do you know that the humidity went down that was due to the eclipse? I suppose if it's
I mean, it seems like you could just take the data all day, and then look for, some dramatic statistically significant change in whatever's happening on that day.
okay. Why don't we switch over? I think Jill, should we go to you next?
Sure.
Okay.
Let me just.
While she's doing that, so Jackie asked if that has been done. Right, yes. So what has been done?
I don't know. As astronomers, I don't. The people who do this as astronomers are worried about the sun. Not yes. Sorry, sorry. Taking the data all day. I don't know how the globe protocol works. So if you're doing that all the time anyway, then it doesn't matter. You've just got the data continuously forever. I got the impression from what I heard that you were going to do something new on just that day. In which case, you then have to ask, how do you compare that to just standard issue days? So.
Right, there certainly are weather stations that observe surface temperature and air temperature. It's not a lot observing surface temperature. But yeah. Well, all right, we'll turn it over to Jill.
All right. So I have been working on, and I and several other people at Langley have been working on kind of compiling and condensing some of the eclipse information that's available, because NASA has a fantastic website that has all of the information you could possibly want on the eclipse. But if you want kind of a condensed version of just here's what's happening, here's some interesting things you might want to look at, we've been working on kind of condensing it down. So this is similar to what Michael just showed. We have kind of the explanation on the front page just of what the eclipse is, where the path of totality will be, and then we have a set of extra tabs. So safety is the same thing that you'll read on any of the other big websites covering the eclipse. This is taken directly from the NASA website, which has the same stuff as what's on the American Astronomical Society's website. And it all reiterates the same things. It's not safe to look at the sun with your eyes except during totality, and gives you a list of places to go and get eclipse glasses and a list of different ways to observe the eclipse if you don't have eclipse glasses. But given what we were just talking about, I think the globe research ideas is probably what everybody's going to be most interested in. So here I have this figure. This is from that study of the 2015 eclipse over the United Kingdom. And what this figure is on the bottom is solar radiance. So you can see that they had an eclipse earlier in the morning. So the sun came up, there was an eclipse, and they actually only observed a partial eclipse. It was, I think, around 80% over the UK, but the totality didn't pass over the UK at this time. And they had a bunch of citizen scientists take air temperature measurements. And then they also had all of their weather stations across the UK take measurements and collect data as they would normally. And they compared that data one to the days before and after, So that's one way to kind of normalize for the eclipse, by comparing what you would see on a normal day before or after. This study itself used a model to predict, based on the weather at the time and the time of year, what the predicted temperature would be. And the day was actually a little bit warmer than they would expect for a normal day, which is why the leftmost figure of the UK has a lot of pink on it, which took us the longest time to figure out. But as the eclipse came and reached its maximum, the temperature dropped significantly across a large portion of the United Kingdom. And then you see temperatures recovering again as the sun comes back. And so we have that as just an example. We also link to the website for that experiment, which you can find. It's not the easiest or best explained set of links, but it is pretty interesting. And then we recommend a couple of protocols that we think that you would definitely see something if you did a measurement during the eclipse. Air temperature is one where they saw things in the UK. Surface temperature is also somewhere where you're likely to see something. Relative humidity obviously is related to temperature, so that's likely to change, but it might be interesting to also measure total humidity. Some places have noted changes in the clouds, and then wind direction. We don't have a protocol for that for GLOBE exactly, but we do have an instrument recommended to build that is part of our ozone protocol. So we link that. And we're also looking for a couple of good activities on wind speed and wind direction so that we can get good instruments that people can use. Let me take a look at these questions really fast before I continue talking. And everybody, you should feel free to interrupt me and ask questions in general.
Yeah, so Jill, I think it was all good.
Okay, yeah, it looks like everybody knows what's going on here, more or less. So the reason this graph shows more radiance afterwards is because it was morning and somewhat cloudy, I think, in the morning, but the sun kept coming up, and usually you'll have highest irradiance in right after noon or early afternoon. So that's why it kept going up after the eclipse was completed. Oops, sorry. What is the maximum amount that cloud cover can be before we won't be able to see the eclipse? You know, I don't know the answer to that question. I know that in the path of totality, that even if the cloud cover is complete, you'll notice a darkening one way, even if it's completely covered, because you're still not getting sun on the top of the clouds. It's like nighttime, essentially. And I did want to point out, and there are a couple of other things I wanted to point out on this website just really fast. We had highlighted a couple of learning activities and demos that were really easy to use and well explained. And most of these also have, at least the two at the top, have Spanish instructions as well. So these are some really good demos. We also have more about the eclipse, where the first thing that you'll see here is a table of when the eclipse begins, when totality starts, when you'll have the maximum eclipse, and then a link to an interactive map showing eclipse times all across the American continent, North American continent. And we'd really like to see people use the discussions and documents page. There's not a lot up here yet, but we'd like to have a bunch of conversations like what we're having in the chat only on this page, so people can all participate and use this data and continue chatting with each other, kind of brainstorming together. We kind of specifically did not put explicit ideas for projects to do on the Globe Research Ideas. We just put some protocols that we thought you might see something, because we want people to try and come up with their own experiments during the eclipse. And then there was one more thing I wanted to show that's just a plug for the Globe Observer app. During the eclipse, right before and right after, there will be a special module on the Globe Observer app for air that will take air temperature data, and it will prompt you to collect air temperature data using a Globe protocol approved thermometer at intervals of time before and after totality. It'll also pop up and tell you if you're in totality, don't take measurements, during that time. Enjoy it. And it will prompt you to take measurements in probably 10-minute intervals. And then also the day before and the day after, so you can kind of get an idea of how much of what you saw was due to the eclipse versus just normal changes in temperature. And the people over at the Globe Observer app development side are getting ready for big influxes of data, and they're pretty excited about that. So just wanted to let you know that's coming up. If there are any questions, any more questions, let me know. And if not, then
Jill, I think that I really appreciate your pointing out that page. That's something that we can print out and share with all of our teachers. I think the idea of enjoying the totality, enjoying the experience as it's happening was really important.
Mm-hmm.
Because it really is a unique, and that was on the Globe website. Is that on the Globe website or on the Globe Observer?
It's on the Globe Observer. Let me send the link to the chat. It's right here.
So this is something that we could send to our teachers. It's really good advice.
Yeah, and it's something you'll see repeated at most of the NASA sites that have, even the ones that are talking about how to take pictures or do filming. They'll say, you know, put your camera away during totality and just enjoy.
Where does it actually say that on here? Does it?
You know, it may not actually say on this website, but that there will be a pop-up on the app. No, so if you scroll down below the black and white Eclipse graphic, it says, especially for first-time Eclipse observers, we recommend you put down your phone or camera during the few minutes of totality and just enjoy the experience.
Jill, I have a question. Do you know if, so the Observer app people, when they get that additional option developed, do you think they'll put some screenshots of the new option of the app, maybe on the Globe website? I'm just wondering if we can share that then, you know, maybe later on with our teachers.
I do think they will. And that's kind of a self-serving, yes, I think they will, because I can just ask them and make sure that we put that up there, because that's definitely something that we should send out. And I think they said they should have some mock-ups by mid-June, probably. They're really working hard on putting out the Globe mosquito protocol first, but then it's all Eclipse all the time. And it'll be kind of a nice, concise, and compact place to collect data, which will be nice. Can you find out more about the model used to predict the difference from predicted temperature? Yes. So there are 2 papers that are linked in this on the site, and they're both open access. Let me I can send those links while somebody else is talking. I think I don't have I have the wind changes one up right now, but not the temperature one. But yes, there's actually a really extensive set of papers about that set of experiments done in the UK. And a lot of them are written to be pretty accessible. The first one that describes the experiment is here. So this one is about what the experiment was, how they recruited citizen scientists, what the citizen scientists did exactly. That's there. And it also takes a look at how their measurements did. And then I will find the temperature one and link it in just a moment. Yes, thank you. And then there's also the one, this is a bit heavier reading, but this is about the wind changes that they saw from the eclipse. And then there's a more kind of popular science article written on similar studies here that's also on eclipse winds. And those are all linked from the globe website. Any other questions?
This is really interesting. Thanks, Jill.
Of course. There's some really neat stuff that really went all out on that one.
So Vicky wants the globe site to include those images. I know we're talking about linking to globe, those are, which is that goes 16 now. So,
As for could data loggers be used to collect temperature data, I would say absolutely. I don't know if you'd be able to upload that data via Globe Observer, but I think the Globe protocols have the weather bug data loggers that you can use to upload data to the Globe site. And there are plenty of other data loggers that you could use yourself for experiments. I could talk for days about that, but I won't.
well, and also Globe, you can set up an automated weather station.
Mm-hmm.
So I think there's about 30 in the U.S. right now of Davis. Davis is the brand. But anyway, there's 4 different types that you can use pretty much. The weather stations. All right, should we move on then? Sarah, you had some
Sure.
links to talk about?
Yeah, absolutely. So all those links, it's very apparent we could easily get lost and spend tons and tons of time finding so much amazing information about the eclipse. So what I did actually is went through and just tried to hit the highlights for our teachers and educators in general, and just kind of found the basic ones. Hold on one second. Okay, little delay. So I put together this list of links and resources, and specifically for our Globe teachers. And the first 2 links that are on there are actually the ones that Jill just talked about. So it's Globe's website dedicated to the eclipse. And so that link is there for you. And then, of course, the Observer app. But I was unaware that there would be that update to the Observer app. So that's cool to see. So we'll probably keep checking there regularly to get updates on that. The other ones are really great. There's the NASA Total Eclipse Education website. So this is specifically the education area of the eclipse2017.nasa.gov. There's a ton of things on there, and if you click on the K through 12 link, there's activities for all grade levels. The other interesting part is if you take off the education part of that link and just go to that homepage, that's where you can really find all kinds of great information. There's also on here the National Solar Observatory's educator page. And I tried to make all of these fairly simple links for you so that you can just type them in. On that National Solar Observatory's educators page, there's a great amount of very interesting things, including some of those animations that we saw from Dr. Cushing. In fact, I wonder if I could bring up one second here. So and what I like about this web page, so a lot of web pages are just over the top with graphics and animations and things. This is a nice, simple text list. And so you can just go here and click. So you want to see the shadow moving across the USA, the true shape of the eclipse shadow, summary video, all kinds of great things there for you to explore. in a simple, easy to find format. So the other ones that I put on here, of course, I had to find something from NSTA. There's an 8-page color printable guide on the basics of what a solar eclipse is, how to safely observe it. So a very concise kind of manual of sorts that you could hand out. And then the PBS website for Teach About the 2017 Solar Eclipse is really great. They have something called the Teacher Toolkit. And in there is all kinds of ideas for lesson plans and activities and things. And that was a really long website, so I converted it to a tiny URL so you could just type that one in there. And so this is, what I'm showing you right now is actually, can be printed as a one-page front and back handout. And we can, we'll get this to you guys if you would like it. We'll post it on our various avenues. So in here I also included just the very basics of getting your data onto Globe, defining your site, the link to this sheet for the site definition sheet, the entering your data, another link for the Observer app. Down here is all the ways to connect with us. And then the next part here, so we kind of brainstormed on what this backside should include, and we actually provided here a summary, a data table for you to fill in. And I know that there was some talk earlier about it would be interesting to collect various Globe data all day, which would be fantastic, but we weren't really expecting our teachers to commit the entire day. So we put starting at 60 minutes before totality and then every 10 minutes leading up to totality. And then here we do have it on here. No need during totality to collect any data, just enjoy the view. And then another 60 minutes after that, so every 10 minutes. And what we put in here were percent cloud cover, cloud types, air temperature, and surface temperature. And we decided to reduce the surface temperature protocol instead of 9 random readings, just 3 random readings and take an average. And at the bottom here, there's just another list of resources for you. So hopefully this is a nice comprehensive one-page handout for our educators. And again, we can get this to you, and it's maybe even possible that if you need hard copies, we might be able to do that for you. So I'll open up for any questions and stop sharing my screen. Okay. So Jackie, we can email it to all the teachers, and we'll also post it on our Globe Mission Earth website. On I think we can get it onto Facebook, something that size. Yeah, all the avenues we can push it out there, we will.
Oh, yeah. Do you have a URL right now for it? Is it anywhere on the internet?
Well, what I could do is grab really quickly my Dropbox link for it and put that on there. But I think Jackie was asking about the link for our Globe Mission Earth site. So I don't know, Dr. Seed, if you want to do that while I'm getting the Dropbox link. And Melody, do we have a good resource for Eclipse glasses? We have a bunch of Eclipse glasses. Dr. C, I don't know if we can go ahead and distribute some of those to our teachers, but we have a ton of them.
Well, yeah, we bought 1,000.
Yeah.
We used probably about 200 so far.
Okay.
Yeah, you have to be really nice.
So we distributed nearly all of ours yesterday to our teachers, and if there are any extras, we may be in touch if you have any extras.
I don't think we'll have extras. I think we'll go through them. So I'm doing now the Globe Mission Earth website, Facebook page, the YouTube page.
And we ordered a bunch of Eclipse glasses to Langley. They're not here yet, but we should have a lot that we can send out.
Great to know.
There it is, the resource. All right, are there any last questions? That's a dramatic pause. I want to thank everybody for tuning in, and thank you, Michael, for the great presentation, and Joe, all the great links, and then and Sarah for your work too on the 2-pager, front and back 1-pager, and everybody for tuning in. We're not going to have any webinars now for the rest of the summer, and we'll start back up in the fall, and we already have some ideas of what kind of things we want to do next year for our webinars. So I hope you can join us then. Have a good night, everybody.